Okay, so I will start now. Okay. So, hello everyone. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. So, today we are going to discuss about week 1 assignment, multivariable calculus. I hope screen is visible to everyone. Okay. Yeah, so if you have any doubt, you can ask in between. You can stop me and ask in between. Okay, so as the name suggests, we are going to talk about multivariable calculus. Means we are going to talk about continuity, differentiability, limit of several variable functions. Okay, so let us say uh, you have a function. Okay, so you have a function in three variable. Okay, so in three variable, once you have a function, so this will let us say this will uh, send to some real valued function. Okay, I mean real value. Okay, so once you have such kind of function, it is difficult to draw the graph of this function. Okay, uh, so because you need some extra dimension. Okay, so you need some w, okay, which will vary in r, and so at each point you will get some value of f of x y z. I am denoting it with w. Okay, so it is hard to draw the graph of this function because we don't have tools. Okay, I mean to because we need some extra dimension. Okay, we have only in three dimension it is easy. Okay, so what we will do, for such functions we will choose a constant. Okay, and that so suppose let us choose a constant c such that f of x comma y comma z is equals to c. Okay, now we can draw the graph of such function. Okay, so like in this situation we can draw the graph. Okay, so such thing is known as level surfaces. Okay, so the first question is, so let f of x comma y comma z is equals to x plus y minus z upon 2x minus y minus z. Okay, so we have to find the equation of level surface. So find the equation of the level surface. Find the equation of the level surface for f which passing through a particular point. So which passing through say uh, let us say p1 minus 1 and 1. Okay, so this is our first question. So equation of level surface in general looks like z is equals to c. Okay, so okay, so here your f of x comma y comma z is x plus y minus z upon 2x minus y minus z is equals to c. Okay, so this will imply x plus y minus z is equals to 2cx minus cy minus cz. Okay, So this will give you 2c minus 1 x minus c plus 1 into y plus 1 minus c into z is equals to 0. So this is the equation of the level surface. Now this level surface passes through this point 1 minus 1 comma 1. So this, once you put x equals to 1, y equals to minus 1 and z equals to 1, this will satisfy this one. Okay, so this equation will become, right, at p1 minus 1. Okay, so at this point we have 2c minus 1 plus c plus 1 plus 1 minus c is equals to 0. Okay, so from here you will get c is equals to 1 by 2. Okay, so if I am doing any calculation mistake, please let me know. Okay, so I think this is correct. This will be c equals to 1 by 2. Okay, so c got cancelled and this one, so I think it will be c equals to minus 1 by 2. Okay, so now you got c equals to minus 1 by 2. Okay, so equation of level surface will be x plus y minus z upon 2x minus y minus z, 2x minus y minus z is equals to minus 1 by 2. Okay, so this will give you 2x plus 2y minus 2z is equals to minus 2x plus y plus z. This implies 4x plus y minus 3z is equals to 0. Okay, so this is the equation of your level surface. This is the desired equation of okay. So level surface is like this. Okay, so you have a 3 variable. Okay, so once you have a 2 variable and you fix a constant and c, like if you have a f of x comma y is equals to c, then such thing is known as level curves. Okay, fine. So like if you put, like in the case of level surface, if you have x plus y square minus z square and you put x plus y square minus z square equals to 0, you will get the parabola. Okay, so something like this in that case, x plus square, so say, let me write it down somewhere else. Okay, so in the case you have, so let us say x square plus y square minus z square equals to 0. So it is 0. Then in this case you will get a paraboloid kind of thing. Okay, so it is going infinitely. Okay, so such kind of thing you will get. So once you have a level surface, it is like you can draw the graph of the surface. Okay, so I hope it is clear about the level surfaces, level surface and level curves. Is it fine? Can anyone please respond? Okay, so I can see some comments. Is it assignment 1 question 4? So this is this year assignment? Assignment 1? Suraj Kumar? Is it this year assignment? I think I did some mistake because this will be Z, isn't it? Should be Z. Yeah, Suraj Kumar, assignment 1 question number 4. Is it this year assignment 2023? Because we are not allowed to discuss this year assignment. Okay, that you have to do on your own. We are just helping you out how to solve those problems by discussing previous assignment or making assignments on our own selves. Is it clear, Suraj? Okay, Karina, please explain level surface and level curves once again at last. Okay, at the last I will explain again. Okay, so now let us move towards next question. So we'll talk about some limit questions and like limit of the function and partial derivatives. In question number 5, I'm having doubt that these questions, question number 5 and question number 4, is it previous year assignment question or this year assignment questions? Please let me know, then only I can help. Because this year assignment question we are not allowed to like discuss on that one. This year, yeah. So this one you have to do on your own. Anyhow, I will discuss about the double limit problem so that you can try that problem. Okay, so just let me look at the next question. Okay. So next question is related to the continuity. Okay. So let me first say something about the continuous. So say you have a function f such that Rn to Rm. Okay. So f is said to be f is said to be continuous at some point, let us say x is equals to a, if limit x tends to a, f of x is equals to f of a. Okay, basic definition. Now let us move towards the question. So the question is, your f of x comma y is x root over x plus 2 root x minus y root y minus 2 root y upon root over x minus root over y and k. X is not equals to y when x is equals to y. So it is given that f is continuous. F is continuous at 0 comma 0 if f is continuous at the 0 comma 0, then what is the value of k? Okay, so let us solve this problem. Okay, so since it is given that f is continuous at 0 comma 0, okay, so which means that limit x comma y tends to 0 comma 0, f of x comma y is equals to 0 comma sorry, f of x y is equals to 0. Oh sorry, f of this should be f of 0 comma 0, and f of 0 comma 0 is nothing but k. Okay, so basically to find the value of k we have to find the limit of this function when x comma y tends to 0 comma 0. Okay, so limit of x root over x plus 2 root over x minus y root over y minus 2 root over y 2 root y upon under root x minus under root y. Okay, so we have to find the limit of this function. So observe that this numerator can be written in terms of denominator. You have to divide it. So so I will write it down. Wait. Okay, so once you do this thing, root over x root over root x 2 root x minus y root y minus 2 root y. This is nothing but 2 plus x into root over x minus y plus x minus y into root y. Okay, I hope this is clear. Yeah. So now the limit becomes 2 plus x minus under root y, and observe that this x minus y I can write like this into 1 under root x minus under root y into under root y upon under root x minus under root y. Okay, so now this under root x minus under root y will get cancelled. So limit x comma y tends to 0 comma 0, you will get 2 plus x plus under root x minus root y into root y. Now this is nothing but 2. So the value of k is 2. So to f be continuous, this k has to be 2. Okay? Is it clear to everyone? Okay. So where can we get last year assignment for practice? So these questions I am like these questions are from last year assignment only. Okay. So I'm just solving those questions. Is it okay, Karina? Yeah. Now let us talk about we will talk about partial derivatives. Before that, let us see something which is quite interesting. This is f of x comma y to xy upon x square plus y square. X comma y is not equals to 0 comma 0 and 0 when x comma y is equals to 0 comma 0. Okay, so in this case uh, so we have to check so first thing is, so we will separate the limits and we will see what will happen. Okay, so these things we need to check. Okay, so these things we need to check. So just see the solution. So let f of x comma y is equals to 2xy upon x square plus y square, where x comma y is not equals to 0 comma 0, and 0 when x comma y equals to 0. Okay, so now once you calculate the limit x tends to 0, limit y tends to 0, f of x comma y. So this means that first you have to take limit y tends to 0, and then whatever the value you will get, you take the limit x tends to 0. So once you're taking limit y tends to 0, x remain unchanged. Okay, means you have to take it as a constant. So as y tends to 0, obviously this thing will go to 0. Okay, and then limit x tends to 0 will make no change. So this will be 0. Also, limit y tends to 0, limit x tends to 0, y, this is again 0 because in the numerator x and x into y is there. Okay, so this is also 0. And let me tell you one more thing. In general, these two limits are not equal. Okay, once your f is continuous, then you can say that these are equal. Okay, so Suraj, after this class live session, I will upload the recording of this session on my YouTube link. Okay, YouTube link has been shared to you. Okay, so from there you can go and see the lecture again. Is it clear, Suraj? Yeah. Now we need to check the continuity of f. So for this, we need to check the limit x comma y tends to 0 comma 0 2xy upon x square plus y square. So if f is continuous, this limit has to be equals to 0 because f of 0 comma 0 is 0. Okay. Okay, so let us see that one. So once you see the function, it is easy to observe what kind of path we should take. Okay, so let us take y equals to mx. Okay, so limit x comma y tends to 0 comma 0. This will be 2x square upon 1 plus m square into x square. So this will be 2 into 1 plus m square. Okay, thus limit depends upon m. Limit depends on m, and hence f is not continuous at 0 comma 0. Okay, I hope it is clear. It is clear to you, everyone?
Sir, why did you put y equals to mx?
Yeah, so in in several variable, so suppose if you have a real line, okay, so in the real variable case, one variable case, once you are taking the limit, so suppose you are going to 1. So to approach to 1, you have only one path, like this radial path only. Okay, either you go from right or you go from left. Okay, but in the several variable, like suppose you have a 2 variable, you are approaching to 0, suppose, so you can approach from here, from x-axis, like lot of paths are there. Okay, approaching to 0. Okay, so if you choose a path, so if this limit depends upon the path, means f is not continuous. Okay, is it clear to you?
Yes, sir.
Yeah, because if we choose y equals to x, this limit will be 2. 2 by 2 is 1. If it if you take m equals to 2, limit will be different. Okay, so means it is not continuous, means it is depending upon the path. That should not be the case with the continuous function. Whatever the path you take, you should get the same limit. Okay, for the continuous one. Okay, so this thing is clear, I hope. So this is true, this is true, this is false. Okay, f is not continuous. Okay, so next I am going to talk about the partial derivative. For that, first I will talk about the. Okay, I hope everyone is familiar with the derivatives. Anyhow, first I will talk about the directional derivative, and then we will talk about the partial derivative, because partial derivative is a kind of particular case of directional derivative. Okay, so in general I will talk about this one, but the questions, whatever will work, will be in 2 or 3 dimension only. Okay, so let us talk about directional derivative. Okay, so first I will learn the definitions. So let E be a subset of Rn, and f such that E to Rm be a function. Okay, let x naught be an interior point of E. Okay, so let x naught be an interior point of E, and let V be any vector. V be a vector in Rn. Okay, so we say that f is differentiable in the direction v at x naught if the following limit exists. So what is the following limit? So limit t tends to 0, f of x naught plus tv minus f of x naught upon t. Okay, so if this limit exists, we say that f is differentiable in the direction v at x naught. Okay, and we denote it by dv f of x naught, which means directional derivative of f at x naught in the direction v. Okay, this is equals to limit t tends to 0, f of x naught plus tv minus f of x naught upon t. I hope the definition is clear to everyone. Hello? Is it clear to everyone?
Yes, sir.
Okay, fine. So now, if you observe that, now if you take this vector v, so let us talk about the two variable case, partial derivative with respect to x and partial derivative with respect to y. So if you take this v, small v equals to 1 comma 0, then this is nothing but the partial derivative of f with respect to x at point x naught, isn't it? So what I'm saying is, if you take, if let us say v equals to 1 comma 0 in this one, and your, okay, so so this limit will be, so what we know is, uh, definition of del f by del x at x naught, what is this? Limit h tends to 0. Okay, so let us say, wait, let us say this capital X naught. So let us say this capital X naught has the coordinate x naught comma y naught. Okay, so limit h tends to 0, f of x naught plus h comma y naught minus f of x naught comma y naught upon h. This is the definition of partial derivative with respect to x at x naught, isn't it? Okay. So once you put the value t equals to 1 comma 0, you will get the same thing. V equals to 1 comma 0, you will get the same thing. So once you put v equals to 1 comma 0, this limit will become limit t tends to 0 f of, let us say x naught is x naught plus t. So this is nothing but x naught comma y naught plus t into 1 comma 0 minus f of x naught comma y naught upon t. This is nothing but limit t tends to 0 f of x naught plus t comma y naught minus f of x naught comma y naught upon t. And this is nothing but del f by del x at point x naught. Okay, so means, now let me write precisely. So if v equals to 1 comma 0 means the unit vector on x-axis, you will get dv, directional derivative of f at x naught in the direction v is nothing but partial derivative of f with respect to x at point x naught. Similarly, if v is 0 comma 1, your directional derivative becomes directional derivative of f at x naught in this direction v is nothing but partial derivative of f with respect to y at point x naught. I hope this is clear. Is it clear to everyone?
Yes, sir.
Okay, good. So in the later class, we will see the relation between directional derivative, partial derivative, and differentiation, how the existence of one implies the second, whether it is true or not in general. Those things we will see. Even how these things are related with the continuity. Okay. So let us solve one problem regarding the partial derivative. So let f of x comma y is equals to x cube minus xy square upon x square plus y square. X comma y is not equals to 0 comma 0, and 0 when x comma y equals to 0 comma 0. Okay, so del f by del x at 0 comma 0 is a, and del f by del y at 0 comma 0 is b. So we need to find a comma b. What is a comma b? So del f by del x, partial derivative of f with respect to x at the point 0 comma 0 is nothing but limit h tends to 0, okay, f of 0 plus h comma 0 minus f of 0 comma 0 upon h. So this will give you limit h tends to 0, so h cube by h square. So h cube by h square will be h only. So this is h. F of 0 comma 0 is 0. So this will be h minus 0 by h. So this is nothing but 1. So a is equals to 1. Now let us see partial derivative with respect to y. Limit h tends to 0, f of 0 comma 0 plus h minus f of 0 comma 0 upon h. Okay, so this will give you again you have to put the value. So again x is 0, so this will be 0, numerator will be 0. Okay, so this limit will be 0. This is b. So a is equals to 1 and b equals to 0. Okay, now the next question is, this question is also related to partial derivative. Question is the slope of the function, f of x comma y x cube y plus 7xy square minus 5xy plus y square, okay, in y direction at the point 0 comma 1 is, so we need to find this one. So what the question is saying is the slope of the function this in y direction at the point 0 comma 1. Okay, so means this is nothing but directional derivative of f at the point this in the direction of y. Okay, so in the direction of y we can basically take the partial derivative del f by del y at 0 comma 1. This we need to check. Okay, so this is nothing but you have to partially differentiate with respect to y. So this will be x cube plus 14xy minus 5x plus 2y at the point 0 comma 1. Okay, so this you will get 2 only. Okay, so the slope is 2. This is the answer. Okay, clear. Now let us mention lot, let us see some facts about directional derivatives. let us see f of x comma y is equals to x cube upon x square plus y square when x comma y is not equals to 0 comma 0 and 0 when x comma y equals to 0 comma 0. Okay, so we need to find directional derivative of f at 0 comma 0 in the direction v. Let us see in which direction directional derivative exists, means in which direction f is differentiable at 0 comma 0. So for this, so let v is equals to u comma small u comma solve v. Okay, so we need to find the limit t tends to 0 f of so this is your 0 comma 0, so this will be tu comma tv minus f of 0 comma 0 upon t. Okay, so this will be limit t tends to 0, this you will get t cube u cube upon t square u square plus v square into t. Okay, so this will give you limit t tends to 0 u cube upon u square plus v square. So this is nothing but u cube upon u square plus v square, and this exists always because u comma v u square plus v square is non-zero when u comma v is non-zero. Okay. So what is the conclusion? Directional derivative of directional derivative of f at 0 comma 0 in every direction exists. Okay, remark, this we'll see later because this is the content of v2. F is not differentiable, f is not differentiable at 0 comma 0. Okay, so this gives an example of a function whose directional derivative at 0 comma 0 exists in every direction, but that function is not differentiable at 0 comma 0. Okay, so this is for the directional derivative. Let me see the other assignment problems.
Can you please pull up a little bit of the last slide?
This is clear?
Sir, can you please explain it once again?
So this last line says that this function gives you an example of a function whose directional derivative at 0 comma 0 in every direction exists, means partial derivative also exists, but f is not differentiable at 0 comma 0. Okay, this f is not differentiable at 0 comma 0, this we will see in the next class. Is it clear to you?
Yes, sir.
Okay.
So how did we understand that the directional derivative exists in every direction?
Because here we have chosen this v u comma v, okay, and once you take the limit, once you apply the definition, this limit goes to u cube upon u square plus v square, and this will always exist except u square plus v square equals to 0, okay, which is not the case when u comma v is non-zero, isn't it? So this will always exist.
Okay, sir.
This thing will always exist, isn't it?
Yes, sir.
Yeah.
Yes, sir.
Okay. Let us look at the another question. So let f of, let me just write down the question, that f of x comma y is equals to x cube plus 2 squares y upon x square plus y square when x comma y is not equals to 0 comma 0 and 0. Okay, so the condition on delta for which modulus of fxy minus f of 0 comma 0 is less than 0.0 0.03 0.03 whenever 0 is less than y square is less than delta. Okay, solution is, so given x f of x comma y is, what is given to you is x cube plus 2x square y upon x square plus y square when x comma y is not equals to 0 comma 0 and 0 when x comma y equals to 0 comma 0. Okay, you need to check this condition 0 comma 0. So this is nothing but modulus of x cube plus 2x square y upon x square plus y square. This is less than 0.03. So we need to find the a condition on delta such that whenever root over x square plus y square is in this range, we have modulus of x cube plus 2x square y upon x square plus y square is less than 0.03. Okay, I hope the question is clear to everyone.
Yes, sir.
Okay, so here we need some calculations and tricks. What is the previous year assignment? Please send link, sir. I think it is available to you, previous year assignment, isn't it, Suraj? Okay, previous year assignment is, anyhow, I am solving the question from the previous year assignment only. Okay, so next time what I will do, I means in the PDF format I will write down, means in the PDF format I will attach the assignments in this one so that you can see all the questions at once. Is it fine? Okay. So the thing which we have to so modulus of x cube plus 2x square y upon x square plus y square is less than 0.03. Okay, given that your under root x square plus y square is less than delta less than 0. Okay, so once you see from this one, if you take x square common, or you can, what you can do is, so you can just divide it by, so for this let x, so this will be x cube plus x y square. Now you will get 2x square y minus xy square. Okay, so plus 2y. Okay, so again the same thing will come, I think. So 2x square y plus 2y cube. Okay, so anyhow this will not work because again the same thing will come here. X will be replaced by y and this will be replaced by y and x. Okay, so we need to get the condition on delta so that this will hold. Okay, so this happens, this implies x square plus y square is less than delta square, isn't it? So this implies 1 by x square plus y square is greater than 1 by delta square. Okay, okay, so now what we need to do is x square just let me see the calculation. It's 2y. From this one we will get x cube plus 2x square y upon x square plus y square is greater than minus 0.03. Okay, so if your delta is equals to 0.1, delta should be less than at least the epsilon. Cube plus 2x square y is less than 0.03 into x square plus y square And this we will get it as less than delta square into 0.03. Again, if you take, so if x square plus y square is less than delta square, so this quantity, this individual quantity, this x square and y square would also be less than delta square, isn't it?
Yes, sir.
Yeah, because these both quantities are non-negative. Okay, so this will be less than delta square into x plus 2y. Okay, and x plus 2y is again less than, so once this is, okay, so it is, so here we are getting that 1 by x square plus y square is greater than 1 by delta square. Okay, and we have the x cube plus 2x square y upon x square plus y square is less than 0.03. So observe that this is nothing but x cube plus 2x square y into 1 by x square plus y square. Okay, and this is less than 0.03, and this quantity is greater than 1 by delta squares. Okay, so okay, so this is greater than 1 by delta square, and this quantity, you need to find this quantity so that this into this has to be less than 0.03. Okay, for that we need something here. Okay, uh, I will leave this question here, and we will see this question in the next week, because in my solution this delta I am getting 0.01, but if we put delta equals to 0.01, the things will be different. I think some miscalculation is there. Okay, yeah.
Sir, can we do this way that we put x cube upon x square plus y square and then we add plus 2x square y upon x square?
Yeah, fine.
And so x can be written as x in that modulus format into x square in modulus format.
Wait,
So
wait.
x square
So
will definitely
you are
be
saying
smaller than
x
x square
cube upon
plus.
x square plus y square
Uh,
plus 2x
yes,
square
sir.
y upon x square plus y square.
Yes, sir.
Okay.
Sir, and then x cube can be written like this modulus x into x square. and we know that x square will
X
definitely
cube
be
is
smaller or equal to
x cube is what?
x cube can be written as x into x square.
Yeah.
And we know, sir, that x square is definitely smaller or equal to x square plus y square.
Yeah, definitely.
So we can write this full thing as lesser than modulus of x. Because if we put there as 1, then we can directly put it as less than mod x. And then for the second part, we can do the same, and we will get so the total thing will be less than modulus of x plus 2 into modulus of y. So sir, then
No, actually what we have to somehow make this thing into this format. Okay, and since this is less than 0.03, so what would be the range of delta so that this will satisfy? That we need to find it out. Okay, that way is also correct. We can
sir, we
separate.
can also write this as mod of x is less than equal to delta and mod of y is less than equal to delta, and solve it that way.
Yeah. Okay, so mod of x is less than delta and mod of y is less than delta. This what you want to say? See, ultimately what we are doing is we are checking the continuity condition. I mean, for every epsilon greater than 0, there exists a delta such that mod of fx comma y minus f of 0 comma 0 is less than epsilon whenever this modulus of x comma y minus 0 comma 0. So this is nothing but under root x square plus y square. This is norm, let us say, is less than delta. So here epsilon is given 0.03. We need to find the delta. What should be the range of this delta? That we need to find. Okay, I will check this question again because I think in my solution some calculation mistake is there. Yeah, yeah. So the next question is, okay, so let f of x comma y comma z is x square plus e power y upon z by 4 plus 2. We have to find the range of f. Okay. So first let us see whether this function attains 0 or not. Okay. So for this function has to be 0, we need f of x comma y comma z is equals to 0. Okay. So x square plus e to the power y. Okay. So this is always positive and this is also positive, and this cannot be 0 for any xy, isn't it? Is it clear? This cannot be 0 because if this is 0, like suppose x square is 0, you have to e to the power y should be 0. Okay, and e to the power y, this will not be 0. Now the next thing is yeah, one more thing. this all x comma y comma z belongs to R3. Okay, so this first of all, this is this z to the power 4 plus 2. This cannot be 0 also. So this is defined for every z. Okay, so z can vary from uh, minus infinity to infinity. Okay, okay, so now so if you see that whatever the value we will take, this numerator x square plus e to the power y, this will always be greater than 0, isn't it? And z to the power 4 plus 2, this will also be greater than 0, isn't it? Is it clear?
Yes, sir.
Yeah. And now, since this all these functions, whatever in the numerator and denominator, these all functions are continuous. Okay, and this is always positive. So the range is quite clear. So the range of f is 0 comma infinity, in between 0 to infinity. Is it clear?
Yes, sir.
See the next question. Okay, so next question is, so let us consider this function z of x comma y is equals to ln of x square plus 3y square. What would be the domain of G? Okay, so what is the domain of log of x?
X greater than
Yeah, so the domain of ln of x means base e, okay, is 0 to infinity. Okay, so this means that x square plus 3y square, this has to be greater than 0 and less than infinity. Okay,
yes, sir.
okay, now if you see uh, this one, x square plus 3y square, x square plus 3y square is equals to 0. So this will give you that x comma y should be 0 comma 0. Other than that, it can be 0. This cannot be 0 other than 0 comma 0, isn't it?
Yes, sir.
Yeah. So for every point, so for all x comma y belongs to R2 minus 0 comma 0, this will satisfy, let us say 1. Equation 1 satisfies, isn't it?
Yes.
Yeah. So the domain of f is R2 minus 0 comma 0. Okay. So this is open. So basically these questions which I will mention, there we had to check whether the domain is open and bounded. So this is open, that is fine, but not bounded. Okay, now we'll see the next question. Next question is, let h of x comma y is equals to 1 by root over 4 minus x square minus y square. Okay, so we need to check the whether domain of h is open and bounded or not. Okay, so first of all, to this has to be defined, this should not be 0, not equals to 0, and 4 minus x square minus y square should be greater than equals to 0. So combining these two, we will get 4 minus x square minus y square is positive. Okay, clear? So this implies x square plus y square is less than 4. Okay, so this is nothing but a disk centered at origin and radius 4. Okay, so this is nothing but
Radius 2.
sorry, what? Yeah, radius 2. So okay, let's see, this is 2. Okay, so this is open and bounded. Okay, fine. Let us see the next question. For this, let us see, g of x comma y is equals to 2x plus y upon x minus y. Okay, so for this it is easy. So domain for this has for this to be defined, uh, x should not be equals to y. Okay, clear?
Yes.
Yeah, so in R2 we have to remove the line where L is x comma y such that y equals to x. Means from this plane we are removing these lines, y equals to x. Okay, so this is also not bounded. Okay, this is open or not? This is open, isn't it? So this line is a closed set. We are removing this from the plane. So basically we are taking the complement of this line. So this has to be open. Okay. Let us see the next question. So this is v of x comma y is equals to cos inverse of x minus y. So where does the cos inverse define? Cos inverse of x. What is the domain of cos inverse x? So x has to lie between, modulus of x should be less than 1. So for this, modulus of x minus y should be less than 1, isn't it?
So should it be less than equals to 1?
Yeah, less than equals to 1. Yeah. So in this case, if you see, like this will be greater than equals to, like if you can see. Anyhow, this will not be open. Okay. Like such kind of thing. So the set S x comma y such that modulus of x minus y is less than equals to 1 is not open, since x minus y equals to 1 will also be there. Okay, so this is also does not satisfy what we required. So we need only to check which domains are open and bounded. Okay. Is it clear now? Any other question? Let me see. Yeah, so we have solved all the assignment questions except one, which I think in my solution some calculation mistake is there. I will check that question in the next assignment. Okay. So if you have any doubt, you can ask me. Questions are done, previous year assignment question. Yeah, someone said something about please explain level surface and level curves. Karina. Is it clear to you or should I explain it again?
Sir, can you please explain level surfaces and level curves again?
Okay, fine. So once you see this function f of x comma y comma z, okay, that is f such that R3 to R. Okay, so to draw this function, okay, to draw the graph of this function, we need extra dimension. Like we have to draw this function in 4th dimension. Like at each point, you will these points will vary, and you will get a value w. Okay, so you are getting x y z. You are taking x y z, and you are getting the value w. Okay, so drawing this function is not possible, but what we need to do is that once we fix this f of x comma y comma z is equals to c, I mean the collection of s such that x comma y comma z belongs to R3, such that f of x comma y comma z is equals to some constant c. Okay, then in this case it is possible to draw the graph of this function of this s, isn't it? Is it clear? Because in this case what we will do, so like suppose you have some polynomial equation of f, say polynomial in x comma y comma z. Okay, z is in one variable. Okay, yeah, observe that this function f is continuous. Okay, I am talking about the continuous function. Now what we will do is that z, we will write z in terms of something, say p of x comma y and c. Okay, now you can see that this is a function from variable x y. Okay, and you can draw the graph of this function in 3D. Okay, so this surface S is known as level surface. Like if I talk about the function, say f of x comma y comma z is x square plus y square minus z. Okay, I have already mentioned, I think. So if I restrict this function f of, if I collect s is equals to x comma y comma z belongs to R3, such that f of x comma y comma z is equals to, say, 0. So this will become x plus y square minus z is equals to 0. This you will get z is equals to x square plus y square. So in this case, what we are getting is okay. So you'll get a paraboloid curve. Infinite paraboloid. So this you will get. So basically, once you have a function from R3 to R3, it is not possible to draw the graph of that function. So what we will see that, what we will do that we will fix some constant and equal it to the function. Then for that thing, this S will be a surface, means it is a two-dimensional manifold and satisfies the, yeah, so S is a two-dimensional manifold, means at each point you can have a neighborhood which is homeomorphic to an open subset of R2 plane. Okay, this is what I have mentioned here. So see, once you have this one, you can basically get this thing. Like now you have a function in two variable and draw the graph. Okay, so this you can draw in this graph you can draw in 3D. Okay, so such kind of things known as level surfaces. Is it clear now?
Sir, means surfaces of which we can draw the graph in 3D are known as level surfaces.
Yeah, particular kind of thing. Like this should be like this. Is it clear?
Yes, sir.
Okay. Any other question? If you have any question, please ask. Or you can write in the comment box. Karina, is it clear to you? Okay, fine. Nice. Any other question?